All right, so looking at page 44, we're going to tackle the situation where you have some kind of solid that's formed that's not necessarily just relegated to being a thin rod. All right, so we'll jump right into it because it's based off of the same theory from the previous page. Consider a solid formed by revolving the function f of x equals sine of x about the x-axis over the interval of pi over 2 to pi. All right. So let me just draw that quick sketch. So here's our ordinary sine function. They're saying pi over 2 to pi. That's from here to here. Axis of revolution is the x-axis. If the density of the bounded region is given by rho of x is equal to 2x, what is the mass density of the solid? Alright, so we know where it starts and stops. Pi over 2 and pi. So I can throw that in there. Anyway, the rho of x is given as 2x. We're going to multiply that by area dx, which is the same as saying volume. I left it in general terms here because we can come up with the volume a variety of different ways. In this way, the disk method seems most appropriate. So that's what we'll use. So I'm going to have an infinitesimal width rectangle. That's our dx. Its height is y, and that's given as sine of x. We know from the disk method that its area given as pi r squared dx. So pi times my radius, which is y, squared dx, where y, I'll put the pi out in front here, is the sine of x. All right. So pi sine x squared dx. No domain issues here, so we could jump right to it. Pi, math 9, pi over 2, pi 2x sine x, close it up and square it, and a dx at the end, and we're looking at a mass density of 10.0566. All right, no units were given, so we'll just reply with units at the end. Consider a solid formed by revolving the function around the y-axis, about the y-axis on the interval of 1 to 3. So those are y bounds. Oh, dang it, typo. Consider a thin rod. You can see where I did my copy-paste job. All right. So this shouldn't be here. If the density function, density of the bounded region is given by rho of y is equal to 2 sine y, what's the mass density? All right. So this one I'll do on Desmos. F of y is equal to 2y squared. I mean, it's a sideways parabola, but it's also something that if we could avoid having to draw these things out by hand, why not, right? Over the interval of, I believe it said 1 to 3. All right, so 1 less than or equal to y less than or equal to 3. All right, so we're spinning that around the y-axis. All right, so we have an idea of what the function is going to look like, and we just do a rough sketch here. So it's something like this. 1 to 3. All right. So we're looking at over the interval of 1 to 3. We're going to do a pi r squared. So in terms of the bounding here, the assumption is, and I guess I could make this a little clearer in the framework of the problem, is that we're looking at the part of the graph that's bounded between itself and the y-axis, which would be represented with an x. All right, so that's good to go there. X is equal to 2y squared plus 3. All right, so that's going to be my radius. Now I can get rid of my Desmos here, bring this in. So pi r squared, tack on my rho, r is the x, which is 2y squared plus 3. dx makes that area into a volume, and then it goes right into the calculator. So math 9, 1 to 3. This one wasn't bad because they didn't give us stuff in terms of x that we had to manipulate. So it's just a matter of us typing some stuff in. But if they did, we'd have to change things up a little bit. But, you know, enjoy these moments while they last, because they don't always occur. All right, so barring any miscalculation on my part, of course, 1157.793 units. All right.